one of the basic operations that requires for ECG analysis in the curious complex detection. In the next videos, we will overview measure peak detection algorithms and create a simple but efficient complex detector for our system. It may seem that normal ECG peaks and curious complexes are standard and easy to detect, but unfortunately, ECG signal has a complicated and non-stationary nature, and complex shape changes from one human to other. Moreover, complex form varies in different ECG reads. The detection of curious complex is the most substantial task in the automated ECG signal analysis. Once the error peak has been identified, a more detailed parsing of ECG signal is possible. There are four main approaches to the curious detection. Threshold methods, including derivative-based algorithms, methods using regular grammar, correlation methods, and methods based on digital filters. Threshold methods, including derivative-based algorithms, are based on the simple rules for original ECG signal or for its derivatives and its modifications. The typical rule is simple. Detection occurs when a threshold is crossed. This type of method is the simplest, but has low robustness for a noisy signal. Besides, threshold changes are required for signals with the different amplitude and time parameters. We will use threshold method in the detector that we will create in the program example to this model, because it's easy to create and use right now. Methods using regular grammar are based on the pre-elementary segmentation of ECG by signal compression algorithms. An input signal is represented as the sequence of basic elements or tokens, horizontal and inclined segments. The segment signal is subjected to grammatical analysis using an algorithm based on empirical representation of the curious complex structure. Structure methods are characterized by visibility, convenience, versatility, and the ability to reduce the information volume that is needed to describe the signal. However, some drawbacks of structure methods should be noted. Signal formation loses after segmentation. The inability to take into account all variants of the ventricular complex structure, the susceptibility to unexpected changes in the result of the analysis with insignificant random deviations in the form of the input signal. Correlation methods. This method assumes the calculation of the mutual correlation function between the input curious complex and one or more samples of the ventricular complexes. Those samples can be either average models of previously discovered complexes or predefined typical complexes. The ventricular complex can be detected by exceeding the cross-correlation value, the given threshold, which indicate a high degree of linear dependence of the analyzed fragment and the corresponding sample. It will mean similarity of their forms. Such an algorithm gives a good curious complex detection quality even in condition of significant interference. However, the correlation method's implementation for curious complex recognition in the online system are associated with extremely high demand on the process performance and can be implemented only with the use of specialized fast commuting equipment. Next type, based on digital filters. This approach can be considered as one of the variants of the simplified implementation of correlation methods. First, the signal passes through the digital filter or several filters with a frequency response corresponding to the curious complex spectrum obtained by averaging the spectral stimata for a large number of complexes of different morphologies. This is similar to the correlation function between the signal and some standard ventricular complex with the shape corresponding to the impulse response of the applied digital filter. The next step of the analysis is based on the information obtained using the threshold algorithm again. Previously detected curious complex and its reference point, which serves to align the current complex with the average samples for previously found complexes, belonging to the different form classes. Correlation coefficients between the detected complex and all available samples are calculated. Based on the results, the analyzed complex either belongs to one of the previously existing cases or considered to be the first representative of a new class, or is rejected as an artifact. The comparative computational simplicity of the described methods is explained by the fact that easy-to-implement digital features are usually used, and the calculation of the correlation function is performed for each sample at a single point. That is not a function but a cross-correlation coefficient in real. So, there are some bases about peak detection methods. We choose the first derivative-based approach to perform it in MATLAB for curious detection task, because it's fast, easy to use, and simple.